guess it's time. Good afternoon, everyone. I hope you're enjoying the conference as much as I do. Welcome to this session talking about Java and containers. So just the first question, just so that we know each other, who already runs Java application in containers in the room? Okay, almost half of you. Okay, so for the other one, I hope I will convince you that it's valuable to do that. So I'm Mikaël Barbero. I work for the Eclipse Foundation. I'm in the IT relaying team. So for the last couple of months, we've been migrating to a new infrastructure at the foundation based on Kubernetes and OpenShift. So we learned a couple of stuff around running Java application in containers, and today we'd like to share it with you. And the main topic for today is actually how to make more money out of it. So I hope you like the topic. How do you make more money out of Java application in containers? That's very simple. You need to do more with less resources. What are those resources? So the first thing that you want to do is to have a higher throughput, and you want to have this higher throughput much faster than you have today. So you run Java, so you know that the Java application takes some time before the highest throughput is reached. You want to do that even faster. You want to consume less RAM, of course, have a much lower footprint. You want to consume less bandwidth, and here I'm talking about the size of the Docker image. When you redeploy your application frequently, you want to do it as fast as possible, so you want to have the linear image you can. And a bonus would be, that would be awesome, is of course to have the most secure Docker images as possible. But unfortunately, we can't have nice things. If you already run Java containers in Java application inside containers, you may already have met this little nice guy, the killer, out of memory killer, basically kill your containers from time to time. And that's because Java used to be not very nice with Docker, but now actually Java and Docker, they are in kind of love story. They like each other much more. But only since one very specific version, which is Java 8 update 131. And before that, don't even try to run Java application. If you cannot use at least this version, it won't work. You will face this little killer very often. So since 8U131, Java is cloud ready, let's say. The containers limitation, CPU limitations are taken into account automatically, meaning that if you set your Docker image with given limits of CPU, Java will automatically adjust some of its ergonomics, so the number of GC threads that it needs to spawn and stuff like that. And of course, you can always override that with the usual options. If you use a Java version between 8U139 and 191, or Java 9, you can actually also enable or authorize your Java, your JVM to detect the memory settings of your containers. So if you set your containers to limit the container to use only 1 GB of RAM, with those options, your JVM will also detect that it runs in a machine or in the container with only 1 GB of RAM. Good idea is to specify this option to tell your JVM to only use one fraction of this RAM for the heap, because of course JVM is not only about heap, it's also use native memory. So you want to allow to assign only a given fraction of the RAM to the heap. If you can use Java 10 and next, or 8 update 191, which is pretty recent, or later, actually all those settings are automatically detected, and you don't have to specify anything on the command line. Everything is taken into account automatically. There are even new options to set the max RAM percentage that you want to assign to the heap. So instead of assigning a fraction, half, a third, a fourth of the RAM to the heap, you can now specify that you want 73% of the RAM assigned to the heap, so it's much more precise. Of course, the CPU settings are still detected automatically, and you can override this detection with this option, and this option will actually propagate to all the other options that actually need to know the number of processor available to your JVM. If you want to revert to the old behavior, so be not nice at all with your Docker container, just deactivate this option, use Docker container support. By default, it is activated, you just need to put the minus in front of it. So you remember the trick that we talked about earlier for U131 to allow the detection of memory settings in the container? It doesn't work anymore in Java 11. So if you want to have a common set of options for your JVM, it's not really working between 8, 9, 10, and 11. So your JVM will just fail to start with this error. So we are cloud native. We know how to run Java properly and be nice with your containers. Now what? We want to run faster and have a smaller footprint and be more secure. That's where comes a new challenger in the game, and the new challenger is Eclipse OpenG9. So who knows Eclipse OpenG9 in the room already? Okay, just a few of you. So OpenG9, it's a JVM implementation, Java Virtual Machine Specification implementation. You can see it as really a drop-in replacement for hotspot. So you take your OpenJDK that you use every day, you remove hotspot and you put OpenG9 inside it instead, and you get, again, a full OpenJDK distribution. OpenG9 is actually pretty new, so it has been created at the foundation about a year ago, but it used to be a commercial product from IBM since the late 90s, I think it's 1996, so more than 20 years, so it's really not a new implementation, it's already pretty mature. And back in the days, it has been designed to work in constrained environment. And by constrained environment 20 years ago, it means that you had to think in kilobytes instead of megabyte and gigabyte of RAM. Mobile applications these days were really about kilobyte of RAM. And that's good because today, when you run in the cloud, if you want to save money, you actually have to constrain your containers to be very small. If you want to run more of them on a single VM or in a smaller cluster. Something really nice also about OpenG9 is that it supports container setting out of the box. So everything that we've talked about earlier, forget about it. It supports the standard option, use container support, and it's activated by default as well. Also, it's not like hotspot for OpenJDK, where for each release of OpenJDK, you have a different branch of hotspot. So hotspot for OpenJDK 11 cannot work inside hotspot for OpenJDK 8, meaning that if some improvements are done in OpenJDK, in the hotspot version of OpenJDK 11, they are never backported, or it's not easy to backport them to OpenJDK 8 version of hotspot. Here with OpenG9, the same VM can work everywhere. So it's mostly true. The way the project supports all those versions is pretty tricky if you want to know exactly which version supports what. And by supporting, I mean they provide support, and further build need to go to this webpage. So OpenG9 is designed for the cloud, meaning that it starts very fast. You don't want to wait before your application is up. It uses much less memory than hotspot, and the ramp up, so the time between the startup and the reaching of the highest throughput, the best performances, is much faster than hotspot. How does it do it? It has a couple of tricks. The first one, and the most important one, is the class data sharing concept. Think about it exactly as it's a concept to apply mechanical sympathy to the VM. So the class files that you get in a jar, the class file format, is not really close, even by a bit, to what the JVM eventually have as an internal representation of the class file when it's loaded. So the class data sharing thing, what they do is that they serialize. Once it is loaded, you can serialize back a format of the class file that is much closer to the internal representation, meaning that the next time you will load it, it will be much faster. This cache is made very nicely. It is immutable, so it can be shared across JVM. So on a single machine, if you have the same cache shared across 10 JVM, you will only load a single instance of this cache. So it's exactly like the libc on Linux. If not all executable, if you don't static link to the libc, it will be dynamically loaded and shared only loaded once in memory. So of course it improves the footprints and make the startup time much faster. But wait, actually Hotspot also has class data sharing. So it used to have class data sharing for Bootstrap class loader, meaning java.lang and java.utils and stuff like that since Java 5. And you are already using it, you don't need to do anything. It's automatic. But the application class data sharing used to be a commercial feature from the Oracle Hotspot version. So you could activate it since Java 8 update 40 by specifying activate commercial feature stuff and add CDS. But since Java JDK 10, it's free to use as an experimental feature. So it's the same concept. You just serialize something in shared memory, a memory map file between your different instances of JVM. So you have better footprint and better startup time. But where OpenGen9 goes further is that it has a dynamic ahead of time compiler, meaning that this shared class cache does not only contain the a class file format closer to the internal representation of the JVM, it also contains a pre-JITed, a pre-compiled version of your class files, meaning that once you load it, you basically load the binary version of your class file, and you don't have any interpreter anymore that needs to run on your class file. So of course it's not the best, it's not exactly the native binary that you would get after 30 minutes of JIT, because it's only an ahead of time compiler, but it still helps a lot with the startup time, and it helps to reach the better performances much faster. And the thing is, this dynamic ahead of time works while your virtual machine is running, so it updates some part of the cache. So any VMs that start after that will benefit from all the caching that have been happening before. So if you want more detail about that, there is a very nice article on the OpenGen9 blog. But wait again, Hotspot also has a ahead of time compiler, but it's only a static one, meaning that you have to run it before your application actually runs, and it is not linked at all with the class data sharing, meaning that you just store a pre-compiled version of your class file and you will load it at runtime, but it's not linked to the AppCDS feature. Next feature that OpenGen9 provides to offer better performances is it knows how to release back the free memory pages from the heap. So OpenGen9 is able to detect when the application is idling, and then if it detects that in the heap some memory pages are not used at all, it will give it back to the OS. Meaning that if you run on a cluster and one of the nodes contains tens of JVM, and you want to run another VM, but actually the memory request for this JVM is not enough with Hotspot. If you run with OpenGen9, maybe OpenGen9 will have released some memory pages before, and you will be able to start 1, 2, 10 other VM on your machine because it has some free memory back to provision new VM. So it's not activated by default. You need to use these options. There is another option to even further improve the startup time. It's called the X Quick Start. So it does a lot of stuff behind the scene. Think about it as just telling the JIT not to go too far with the optimization. So you will lose a bit of throughput eventually, but you will get much faster, much more quickly. And if you already forgot about all the options that we talked about earlier, you can remember only about one. It's a Xtune virtualized, which is used and defined dedicated for cloud deployment. So where the CPU are the number of CPU are not high. So basically it's a configuration for all the other options dedicated for a cloud environment. So the throughput will be a bit less in the long term, but you will start much faster and use much less memory. So the Xtune virtualize is actually the green bar here. So you can see that it starts very, very fast. It's reached best performances very fast, while the standard OpenG9 takes a bit more time, and the hotspot VM is actually taking much more time. So OpenG9 designed for the cloud. What does it mean in terms of numbers? So it's 40% faster at startup time with the quick start option and the ahead of time compiler. It's 66%, the footprint is 66% smaller after startup, meaning that once you reach the best performances, the memory footprint of your JVM is 66% smaller. And during the ramp up, so during the between the startup and the best performance reached, it used 63% less memory as well. And it reached the highest throughput, so the better performances, 35 times faster than hotspot. Quite impressive. If you want all the details for those numbers, just go there. It's a very nicely done performance benchmark for OpenG9. So if you want to try it, just go to the Eclipse OpenG9 project, or if you want to download the binaries, so the Eclipse OpenG9 project does not provide any binary directly on the website. You need to go to the adoptopenjdk.net. It's an initiative from the London JUG, I think, that provides build for OpenJDK. So here you can download OpenJDK either with hotspot or OpenG9, and they also build Docker images available on Docker Hub. So now we have very fast and very lean JVM that works well in Docker images. So what do we want to reach now? It's much smaller Docker image. Who amongst you already used this kind of directive to define a Docker image? Okay, so you ended up with a Docker image of 1 GB. Basically, it's the base size. And if we have a look actually at the base images available for building Java application, it goes from 250 up to almost a gigabyte. So the number in the bar are not for the total, it's just for the red part, which is the JVM size, and the blue part is the base image size, so the image on which onto which the whole Docker image is built on. So that's already a lot, 250 at least. Here comes a new concept or a new idea about how to build Docker images. It's called Distroless. I like the term, that's why that's the first word in my title. And how does it work? It works because containers are actually not real things. There is no such things as containers. They are certainly not virtual machines, so it doesn't need all the files and all the binaries that you would get in a standard Linux distribution. In a container, you can only put, if you want, you can put only the libraries that your runtime depends on, and a couple of files for user identification, but you don't need any package manager, shells, or any core utils program, ls, find, and stuff like that. And that's exactly what they do at the Distroless project. They build base images to build to build single app Docker images. But why? Why would you get rid of the ls, find, and stuff like that? First of all, the nice thing is that if you put your images through some security scanner, of course the signature knows the signature knows is much better because you only get what is used in your runtime. So you won't get security issue because of I don't know, find or cat or stuff like that that are bundled in almost all Docker images. You only have the libc and OpenSSL, for instance, in your image. So you will get much less security warning. It also helps with knowing what you use and what comes from with your application. And in the context of knowing what are your dependencies, what kind of licenses of your dependencies you are requiring, it's very important. And of course, you have very small images, so in the context of redeploying thousands of times a day, it can improve your cluster performances. So where are we with this Distroless image from Google? Not bad, about 120 megabytes. So 100 megabytes for the Java part and 20 megabytes for the base image part. Can we do better? Yeah, we can do even better. Since Java 9, we can actually create custom Java runtime images. So you can use JLink. It's a program that comes with Java 9 and later version. And with JLink, you say, okay, I only need Java base, Java SQL, and it will create a dedicated JRE for you, which only contains that and the JVM. So it lets you really shrink the size of the JVM. So if we look, for instance, at what are the modules provided by the default JDK 11, you can see that it's a lot. I didn't even count how many of them there are. But if we look at the number of modules that a basic Hello World would need, so this is a basic Hello World application that I did, you just need, of course, a Java-based one and the Hello World module per se. Hello World is not what we want to do, of course. You want to containerize your application, and most of the time it won't be modules ready, so you won't be able to use, sorry, this kind of command line. You want your application is not a module already, so you want to use class path at runtime. So you just want to shrink the JRE that you are building. So for that, you can still use JLink and just add the modules that you need for your application. Let's not take care, we don't care about your application yet. We just need to shrink the JRE for now. And to know what are the modules that you need, use JDEPS on your application, and you will get the list of modules that you need to get there. And this command will eventually create a custom JRE for your application. So if we look at the modules that we need for running the Spring Boot Pet Clinic application, it's already a Spring Boot application, so not a trivial example. It's only 14 modules. And what does it mean in terms of size? If we take the size of the base image for running JDK 11, a Distroless base, it's 15 megabytes. The custom JRE with only Java base is 34 megabytes, plus nothing for just a Hello World. And for the Pet Clinic, it's 60 megabytes of jars, and the custom JRE is only 20 megabytes more than for the Hello World example. So we get 50 megabytes Docker images for Hello World and 110 for the Pet Clinic. So if we put that in the graph, you can see that for the whole Pet Clinic application containerized as Distroless, we are and with a custom JRE, we are almost at the same size as a full JRE with no application running on it. So if you want to put Spring Boot Pet Clinic on top of this one, you would have to need to add 60 megabytes again. So I guess that if I would end now, I would have the question, what about Alpine? So for those of you who don't know Alpine, it's a very small Linux distribution that instead of using libc, use Muzzle and BusyBox. So the Docker image is about 4 megabytes, so that's a very good target to build very small images. But unfortunately, there is no JDK 11 build for Muzzle C. They only build on top of the GNU libc. And even if you do that, so there is a project at OpenJDK to build OpenJDK on top of Muzzle. It's called Portola. But even if you do that, your image will eventually contain the more applications, more binaries that you will need. So it will contain APK, the Alpine Package Manager, and some BusyBox commands, so the find, ls, cat, sed, and stuff like that. So is it good or bad to have these binaries? So to you to decide. Depending on the requirements on security and provenance of the stuff. And even if you can find some images, especially from OpenJDK, Adopt OpenJDK, sorry, that say that it's built on top of Alpine, they are lying to you, because it's not a build of OpenJDK on top of Alpine. It's an Alpine-based Docker image inside which they installed the glibc to run the OpenJDK. So it just uses Alpine as a base image, but for the OpenJDK build inside it is actually exactly the same as in Debian base or Ubuntu base. And if we compare the size of those images that use Alpine, we actually reach exactly the same size, so compared to Distroless, except that you have more. You have those binaries, the busybox commands and APK. Whether it's a good fit or not, it's up to you to decide. Of course, as soon as we get a JDK 11 build on top of Muzzle, you will be able to get rid of this layer and have even smaller images, still with the binaries from Alpine. So how to build those Distroless base image? If you don't know what is the format for a Docker image, think of it simply about a tar file with a file system like that, or a file hierarchy like that, and some metadata. So metadata is the name, the tag, and stuff like that. Really, really simple. So if you want to create your own Docker image manually, and that's what I did here to create the base image for Java, create this file system. If you want some dependencies, download the Debian package on the Debian website. Exactly the same, it's just some archive that you need to put in the file system. Really simple, and you get the whole stuff running very fast. And then you need to build on top of this base image. And for that, I use a multi-stage Docker build. So the first stage is about creating the shrinked JRE, so sorry, the Java runtime environment. So I use the base image where I want to take the version of Java that I need. So here, OpenJDK 11, and then I use JLink to create a shrinked JRE with the modules that I need. So here it's the hello world, and then I use another stage which uses the Distroless base for Java, and I copy from this stage the results of JLink, meaning that this layer will only contain what I copy from there and the base. And then I define the entry point, meaning that when I will Docker run on this Docker image, it will automatically start this application and this very small Docker image. So you may have seen JLink O over here. So it's just a shortcut, because JLink, to have very compressed and very small custom Java runtime images, you need to give a bunch of options. Of course, you will have all of that in the presentation. So now we have Docker and Java running together. We have fast startup, fast JVM, very small footprint, very small images, and the attack surface of your images are reduced because you have only what you need. So if you have any question for me, I think I have a couple of minutes. Yeah. Is there any specific garbage collector? There is no one recommended by default, or at least specific for the the containers. The default one in OpenJ9, I know it's made to run in constrained environments, so with very few CPU, and it takes that into account. And the same for the standard hotspot. The ergonomics use the number of CPU, so there is no specific requirements, at least as far as I know, regarding garbage collection in containers. Yeah. So the question is how the shared classes, they can be shared on the same machine, because of course they have access to the shared memory of the machine. Can they be shared among containers? I don't know. That I wanted to check on that before the talk, and I didn't have time. Sorry. I hope so. Yeah. Any other question? Okay. So then I guess we can conclude. So if you didn't study it yet, I encourage you to migrate to Java 11. The Docker support, if you want Docker support, it's really the way to go. Do not try with previous version, especially if Java 9 and 10, they're already deprecated. If you want to have a look at better performances, try OpenGen9. It's really, really impressive, the gain that you get almost for free. And I hope that I convince you that you should build your own Docker and Java-based images and do not use the Ubuntu or Debian based images for that. Don't forget to evaluate the talks, so mine of course, but also all the other ones that you've attended to. So for that you need to log into the website, go to the talk page and vote +1, 0, and -1 if you didn't like it. And I would like to thank you for your attention, and if you want more information, I have a Docker GitHub a repository that contains some all the examples that I've made and even more. Thank you.